have another negative 40. Okay, so this is still easier than writing those equations, right? So we are aware that the element will rotate at point X, the element will rotate anti-clockwise. Okay, so this is our point X. So what we are given over here, we are given that, so we are going to solve this by using tau max, which is the radius of the circle, is equal to 75 megapascal. Okay. So one possibility is we are going to find tau max, or we are going to find our stress average, okay, at some on the left hand side. Okay, so we are, I'll tell you visually what we're going to do. We are going to find tau max somewhere, or not tau max, our stress average. Okay, so I don't know where is it yet because I cannot draw 75, right? So we are going to find our stress average.
Eugene?
Yes.
Can I ask why you knew point X was on the negative 40?
Because the element rotation at point X, right, the arrow is going up and the element will rotate in an anti-clockwise direction. So when element rotate anti-clockwise direction, right, for this case, anti-clockwise is at the bottom.
Okay, that makes sense. Thank you.
Okay. So we are going to find our stress average one. So what we know, right, what we know is the height from here to here is 40. And we know that the radius is 75, right? So we want to find the stress average one. Okay, so stress average one is equal to square root, or before we square root, we must take at minus 70 minus by square root of 40 squared, or not 40 squared, you cannot square root, 75 squared minus by 40 squared. Okay. So this will be equal to my calculator. Got it. So this is equal to 75 squared minus 40 squared, square root the whole thing. So minus 70 minus by 63.442. So it's equal to minus 70 minus 63.442 is equal to minus 133.442. Okay, so I'm going to, wow, my eyeball is pretty good, my first guess, bloody hell, right? So we have found our stress average to be here. Okay. So I'm going to use green. For our stress average line. So this is 130, 150, 133, somewhere around here. So this point over here is our stress average one. Okay. Then I draw the whole line across. Right. So what we just found is the distance from here to here. This distance right, is equal to 63.442. Okay. And then we now want to find this position, which is our y. Now, y is at that position where it crosses the positive 40 or the clockwise 40 rotation of the element, because y as you can see down here, this Y value has a what? Shear of what? 40 megapascal. Okay, so we got that. So to find where stress Y is, it's real straightforward. Okay, so I call it stress Y1. Okay, so stress Y1 is equal to minus 133.442 minus by 63.442. Okay, so 133.442 plus 63.442 is equal to 196 minus 196.884. Okay, and that's 196.884. So this is our point Y1. Okay, so now we are going to construct a Mohr circle now. Okay, we are going to construct a Mohr circle. So we are going to draw our Mohr circle now. So I'm going to determine where the principal stress are, right? So it is 133.442 plus 175, 208. Okay, so this is our Mohr circle, XY plane Mohr circle. So 208, so somewhere around here. And then it will come over here. Wait, so 70 minus 133.442 minus 75, 58. I'm having a bit of a brain fart down here. Hold on. 58. So 58. Okay. So the maximum shear is 75. So this is 75. And then this is 75. Okay. Okay, so this is our first Mohr circle. And this belongs to our XY plane. And it is our in plane. Okay. We also know where point Z is. So over here, this is where our point Z is. Then we sketch another circle for point Z. Okay, so we sketch. So I'm going to 2, 4, 30. So again, this is eyeballing. Okay. Okay. So this one over here, it belongs to our XZ plane and is our out of plane. And we have one more circle. So the last circle is this circle over here. And we will go out a bit, somewhere around there. We'll go out a bit. Okay. So the last circle over here, let me draw the point elsewhere. Okay. The last circle that I've just drawn, this is our YZ plane. And this is our out of plane. Okay. Right. Now, this is the 3D Mohr circle for one of the possible Y value. Okay. Now, given what we are given is the maximum shear stress in any condition is what? 75 what? Megapascal. So what does this mean? Okay. So the element cannot go, sorry, the Mohr circle cannot go out the 75. Okay, so I'm going to draw the 75 line. This is not a good color. I'm going to use pink color. This is our 75, right? And then I'm going to pull across by 150. Okay. I'm going to pull across by 150. So this is our shear max 75, our normal stress of twice of the tau max, which is equal to 150. Okay, right? So what we have just done is we have incorporated the allowable maximum stress, for example, our U stress. Okay, our U stress. So this over here is also equal to our stress U. Right? It's twice because this is in fact the radius of the circle, yes or no? Right? So we know stress Z is always anchored there. So stress Z is our anchor. Stress Z cannot go anywhere. It's pinned down there. 2 points we are very sure is point X and point what? Point Z. Yes? Right? So when that's the case, when you look at a situation like that, right? Focus on the pink line, right? Anywhere the circle cannot go outside the pink line. If it go outside the pink line, right, we are doomed. Okay, we cannot go outside the pink line. Unfortunately, this solution, right, when we construct 2D Mohr circle or when we go into 3D Mohr circle, 2 of the circles went outside the what? The boundary. Yes or no? So the outcome from this is not a possible solution. So stress Y cannot be at that value at all. Okay, because it's outside the what? Boundary. Okay. Go on, give me a second. Okay, so you guys can copy this. I'm going to post in the solution. I'm going to compress it. Come on, you stupid thing. Can you go up? You can go up. Okay. Okay, now you can go up, can you? You still cannot go up, you stupid thing. Undo. Okay, ignore me, okay? I was doing something ridiculous. Okay, I have a question. Is it a general rule? Later on, I'll write up the formula, Arisha, okay? Yeah, you want to say, is it a general rule? The answer is yes, okay? That the stress yield is twice of stress max, or shear stress max, okay? So now you know why that this is not a possible what? Solution. Okay, it cannot be because the circle are outside the what? Boundary. Are we clear? Okay. So this is one possibility. The one possibility will be invalid. Okay. So now this is drawing what? Just by constructing Mohr circle. It's easy. Yes? Okay. If you look at the solution manual, what they have just done is they have just done this. Okay. We did not calculate 28. We have 13.44. We have what? 196.88. If you look over here, we have 133.442, 196.884. I hope I convince you to use what? Mohr circle. Because visually, you can understand what is going on. Okay, by the way, I will elaborate this, okay? I was an expert witness in another case where the structure went wrong, okay? And I explained this. Guess what? The judge, as I said, only had high school physics. He could understand this, okay? If I were to show a bunch of formulas, good luck, okay? No way, okay? Right, I'm going to stop here. I'll see you guys again tomorrow. Tomorrow will be interesting, okay? Tomorrow, we're going to have another 2 different situations, and we're going to design a shaft under rotation, okay? So come back happy. Come back happy. Eugene, seriously? What an ending.